Welcome to our deep dive into the Parker Solar Probe, humanity's first mission to touch the sun. Now, when I say touch, I'm talking about getting so close to the sun that it's actually flying through the sun's outer atmosphere, the corona. This is no mean feat, folks. The sun is a blazing inferno, a gigantic ball of plasma that makes life on Earth possible but also poses a serious challenge to anything that dares to get too close. So, how do you send a spacecraft to an environment that can reach millions of degrees? That's exactly what we're going to explore today as we delve into the incredible engineering and groundbreaking science of the Parker Solar Probe. The Parker Solar Probe's mission is to dive deep into the sun's atmosphere, closer than any spacecraft before. It's not just about breaking records, though. The probe is on a mission to answer some of the most fundamental questions about our star. Think about it. The sun is the source of all energy on Earth, driving our weather, climate, and even allowing life itself to flourish. Yet we still don't fully understand how it works. The Parker Solar Probe embarked on its journey on August 12, 2018, blasting off from Cape Canaveral Air Force Station. Imagine the power needed to fling a spacecraft toward a star nearly 100 times wider than our own planet. But it's not just about brute force. The launch was a delicate dance of physics and engineering, carefully calculated to set the probe on a trajectory that would bring it closer and closer to the sun over its 7-year mission. Hold on to your hats, folks, because the Parker Solar Probe is the fastest human-made object ever built. At its top speed, it's zipping around the sun at 430,000 miles per hour. To put that into perspective, that's like traveling from New York City to Los Angeles in less than 1 second. This incredible speed is essential for the probe to slingshot around the sun, using the star's own gravity to propel itself closer on each orbit. Chapter 4. A sun-kissed orbit 3.83 million miles, a daring close encounter. Now, you might think that getting close to the sun is a one-way ticket to a fiery demise, but the Parker Solar Probe is built to withstand the heat. At its closest approach, it'll be just 3.83 million miles from the sun's surface. That's closer than Mercury, the closest planet to the sun. This daring proximity is what allows the probe to sample the sun's corona directly, gathering data that would be impossible to obtain from afar. Chapter 5. Beating the Heat, 2,500 degrees Fahrenheit, the science of the heat shield. Imagine trying to keep a spacecraft cool while flying directly into a furnace. That's the challenge engineers faced with the Parker Solar Probe, and they came up with an ingenious solution, a revolutionary heat shield. This shield, facing the constant bombardment of solar radiation, can withstand temperatures up to 2,500 degrees Fahrenheit. It's like a giant umbrella, protecting the delicate instruments behind it and allowing the probe to operate in the most extreme environment ever faced by a spacecraft. Chapter 6. Science on Board Fields Whisper Swept Isis, Unraveling the Mysteries of the Sun. The Parker Solar Probe isn't just taking a leisurely stroll around the sun, it's packed with scientific instruments, each designed to unravel the mysteries of our star. It's got fields to measure electric and magnetic fields, Whisper to capture images of the solar wind, Swept to study solar plasma, and ICE to analyze energetic particles. These instruments are like the probe's senses, allowing it to see, hear, and feel the sun in ways never before possible. Chapter 7. Unlocking the Secrets of Solar Wind. Why is the corona hotter than the surface? One of the biggest questions the Parker Solar Probe aims to answer is the mystery of the solar wind and the coronal heating problem. The solar wind is a stream of charged particles constantly flowing from the sun, and it can wreak havoc on our satellites and power grids here on Earth. And here's the weird part. The sun's corona, its outer atmosphere, is hundreds of times hotter than its surface. It's like a pot of water boiling from the top down. The Parker Solar Probe is gathering data to help us understand why. Chapter 8-24. Orbits, 7 years, a grand tour of the sun. The Parker Solar Probe's mission isn't a quick flyby, it's a carefully choreographed dance around the sun. Over 7 years it'll complete 24 orbits, each one bringing it closer and closer to our star. With each pass, the probe dives deeper into the corona, enduring intense heat and radiation to gather data that will rewrite our understanding of the sun. Chapter 9. Data from the Edge. The Deep Space Network. Phoning home from millions of miles away. Imagine trying to send a text message from millions of miles away, with the sun trying to interfere with your signal. That's the challenge the Parker Solar Probe faces as it transmits its precious data back to Earth. To accomplish this, it relies on the Deep Space Network, a global network of giant radio antennas. These antennas are so sensitive that they can pick up the probe's faint signal, even amidst the roar of the sun. Chapter 10. Honoring a visionary Dr. Eugene Parker, the man who predicted the solar wind. The Parker Solar Probe isn't just a marvel of engineering, it's a testament to the power of human curiosity and the legacy of scientific pioneers. The probe is named after Dr. Eugene Parker, a visionary astrophysicist who first theorized the existence of the solar wind back in 1958. At the time, his idea was met with skepticism, but the Parker Solar Probe is proving him right, gathering data that's revolutionizing our understanding of the sun and its influence on our solar system. Outro. Journey to the Sun, the future of solar exploration. Thanks for joining us on this journey to the sun. The Parker Solar Probe is pushing the boundaries of space exploration, venturing closer to a star than ever before. It's a testament to human ingenuity and our insatiable curiosity to understand the universe around us. And as the probe continues its daring mission, it promises to unlock even more secrets of the sun, revealing the fundamental processes that drive our solar system and shape our place within the cosmos. Don't forget to like, subscribe, and hit the bell icon for more fascinating space explorations.